and then the stemming, because every word, when you talk about the word, say for example, in Manipuri, since like it's a very highly agglutinative language, finding a root is very difficult. Say for example, if I say like Pusin Hanjarang Gadabni Dakot, it's a single word, but the thing is the root word is only Pu. So like even when you go at the semantic level, that single word almost come to a sentence. Like if I say Pusin Hanjarang Gadabni Dako, in English it will be something like, I wish I would have asked him or her to take it. That's the complete meaning of that single word. So it's very complex when we go for the translation of Manipuri to some other language. So that is the reason why we are still struggling for the complete translation work in Manipuri. Maybe like some other language we may be having the same problem, same issue, comparing to some other Indian languages. So the complexity of languages lies depending on the complexity of the, application of all this language in NLP lies in the complexity of the language. So it's not an easy work. Like we have to just break down the suffixes, prefixes, morphemes, all these things are very important. And then that too by machine. Manually I can just segregate the whole word, and then I can just come to a very, the very root. Like in the example, Pu was the only root word. So even if you want to design a dictionary or something, that becomes very important. As I told you yesterday, like the frequency dictionary or something like that. After getting a frequency dictionary, you can set up the whole dictionary after getting the frequency of each and every word. The thing is, like, even though if you get the frequency dictionary, you have to identify the root again. So finding the root again will be another, important task if you really want to design a dictionary. Designing the dictionary, for example, like when I go for the frequency dictionary in the huge corpus, there will be a lot of suffixes and prefixes being added in the word. Even though if it is unique in the whole corpus, the thing is like maybe like some infixes are already added over there. You have to segregate it. So you have to have another program where you can find, identify the root of that word. Once you can find the root of that word, then dictionary designing will be very easy, if I am not wrong, because you have to have the root, and adding this will become verb, adding this will become this, adding this will become that. So that will be easy again. So that is another thing. So stemming is important, and and then that can also be done in the system itself. And then transliteration sometimes is important, because transliteration, if I am talking about transliteration, that means like if you are running with two scripts. The languages sometimes run with two scripts. For example, Manipuri, we run with Bengali script, and then we have another script called Manipur. So we are running with the two script. So like, yes, the government started just mobilizing thing in Maitemek script, but at the beginning, in some tenure of time, it was like Bengali script. We were running with Bengali script. So now the thing is like, it's not a translation, it's just a translation, shifting from one script to another script. So for example, maybe like other languages, I think among you also you'll have languages where you're using two scripts. So in that case, if someone knows one script and another one knows another script, but of same language, then this is another important thing which you can do it. Then morphological segmentation is another important thing. Finding the morpheme is also important. Morpheme and syllable is different thing. That you all know it. Like morpheme identification is important because like you want to find the meaningful unit in a word. Say unlikely lady. So un is there, likely is there. So likely, all these things, like maybe like you sometimes two syllables clubs to form one unit, one morpheme or something like that. So we need to be very careful in identifying the morpheme of each and every word also, because with the addition of this morpheme, the meaning of the word changes. So in the system, it is again an important thing finding the morpheme in the word. So that is one thing. Then the name entity recognition, because like since I have started talking about the name entity recognition yesterday, because when you try to translate something, there may be a confusion by the system, by the computer, whether if you go into the semantic level, then that may bring up ambiguity also. Say for example, Washington, if I take you Washington, Washington can be the name of the person, the president of US. And sometimes Washington is name of a place also. And then Washington can be another thing also. So when you try to translate it, sometimes we need to identify the name, or otherwise sometimes in Indian language what happens is like we try to name a person giving certain, having certain semantic ideas. So if you straight away go with the translation of that particular word, and then there will be a confusion again. So for example, in Manipuri we have a term called chaubo, which means like big. So thing is like if I straight away translate with the semantic idea of that particular word, then that will be something which will be little bit different from what we want in translation. So identifying whether that particular word is a name or not is also important thing. Name, when I say name, it consists of person name, it consists of organization name, it consists of place name, so whatever it be. Even if the time and the currencies are also considered to be name. So we have to identify all these things, because once we go for the translation in some classical way, then these are all important things. So going with the name entity recognition is another important thing. Then you have the optical character recognition. Say for example, people working in image, they generally go with this, because like you have a manuscript which is in the in the form of image, because they used to archive the thing in form of images. So the thing is now like, say for example, if we have Mahabharata or Gita written in a very old this one, so the thing is like there is no editable form. I just want to get the photo of that preserved image or something like that. Now the thing is like after getting the image, I have to convert the thing into editable form, so that it can be used in such a manner that it can be translated to some other languages. So and now the technology is so advanced that once you just get the editable form, it can be translated to any of the language, especially because like there are a lot of languages which gives very high accuracy in translation. Say for example, English and maybe French and all, this two pair of language has given a very high accuracy of translation. You can find it in Google also, like English, if you have a certain document in English, it can be translated into France very easily. Like accuracy is very high also. Similarly, if you have a manuscript, the first thing is to just make it into editable form. So OCR becomes an important part, or otherwise plays an important role in that. Now, then we have parsing. Parsing in sense like you have verb phrase, noun phrase. So like phrase and all, if we can just structure it in a diagrammatic way, or otherwise like the noun phrase, when you have noun phrase, how will be the structure? When you talk about the verb phrase, how will be the structure? And if suppose the system can just find out all those structure, then it is again an easy work for the for the future other related things. Phrase, if you can pick it up in a proper manner, then it will be very useful, because like it can be implemented in multi-word expression also. Why is because in multi-word expression, what happens is like it doesn't carry the real meaning with what you are having. Say for example, to and fro. To and fro is a multi-word expression where if you segregate it, then that will give a different meaning. But when it comes together, that gives a different meaning. So to and fro means like going up and down. But if you segregate it like to and fro, that means like that will be very different. So identifying all these things again becomes important, and with parsing that can also bring you accuracy to up to certain level. So that is one point. Then you have the question answering. Question answering in sense like since like all of you, I will be assuming that you all are teachers and all. Now the thing is like the system, the computer started giving the marks for the answer given by any of the candidates. So like maybe like after some time the teacher may be neglected, since like the debate is on since yesterday, like whether we will be there or not. So this is another area where things can again be changed, because having multiple choice question is very easy, because like ABCD will be there, and then one will be selected. One of the option will be selected, and it can be check it, cross verify it, and then give the answer. But what about the short term answer, long term, answer type, okay, short answer type, so yeah, essay type. So maybe like we may be thinking like it may not be possible to give an accurate mark in that. But now I tell you very frankly, like the system gives a very accurate answer, I mean marking also. Because like when we try to check the answer, we look into certain criteria of the question which is being asked. We look into the context of the question and then the related chapters. Based on that, we pick up some points and then we used to give marks on that. Similarly, the system used to do that, and the application will be somewhere in virtual university, where virtual university will be a reality after some years come down the line. Because we come here to study, we come here to discuss in physical mode. Since because of the corona, we have already started about the virtual classes and all. We go for online classes and everything. So it's almost like a successful one now. Now only problem was with the exam system. In the exam system, we say like it will having a online exam becomes a very difficult one, especially for the essay type of answer. Now with this question answering system, it will not be a tough one. Say for example the virtual university. The advantage of virtual university will be something like this. Like the space occupied by a university in terms of acres will not be there. The university will be owned by a small computer, because the whole university will be there giving in a web portal, where something like www.somethinguniversity.com. That's all. The thing is like you have the another advantage is that you can choose your course anytime. You can just write the exam anytime. You can just join the class anytime, and whenever you feel, you can get the degree anytime. That is another advantage, because if you are smart enough and if you are a person who can learn very fast, you don't need to wait for 4-year, 2-year degree course. That will be enough even within a week also, because if you are very smart, if you want to earn the degree. And moreover, there won't be any faculty involved. Yes, of course, creation of all these learning materials may involve faculties, but that may also not be involved, because since yesterday we have been talking about all this AI generated thing. So the thing is now, when you write the exam, you can write it and you can get the answer script at the instant. As soon as you write the exam, your answer, the marking will be given to you. The marks will be given to you, will be shown to you. And then you can even get the grade as soon as you wrote the exam. So that is the future, because this virtual university is already started in Pakistan. Pakistan has already started, having a virtual university. Okay, maybe like it may soon come to India also, but maybe because of some restriction by the government, it may be restricted, but it's happening in other part of the world. So this is another important area.
Sir, NPTEL is also doing the same thing. NPTEL?
Yeah, NPTEL is another example. NPTEL gives a certain period of time to write the exam. But if suppose someone can learn it very fast, then that may also be removed. The period may also be removed. And NPTEL is one of the examples. SWAYAM and all these things are one of the examples. But the thing is like when you go for the whole complete course and certification, that will be a little bit different, but almost the same thing what Madam has already mentioned, like about the NPTEL, SWAYAM courses and all. This is the starting thing. So that will be the future again. Now the sentiment analysis. I was talking about the sentiment yesterday, that this robot will start loving you, the robot will get angry. All these things are happening now, because like the sentiment, if I'm talking about in NLP also, we can find the sentiment analysis. Because when, say for example, I'll give you an example applying in forensic science. If suppose someone is dead, so then when we check into the message passed by him or her just before he died, then we can just assume whether what sentiment he or she was having. Then we can just conclude whether it's a suicide or a murder or something like that. Because when someone write a message just before he or she died, the way how she wrote can be another point of another point where we can examine. Because someone who is happy will definitely type a message in a very happy way, and someone who is in the suicidal mode, he or she will be typing the message in such a manner like she is in a very stressed mode, or maybe like she is something different. He or she is something different. Looking into that, we can just finalize like what type of sentiment that person was having. So looking into that, if suppose she was very sad and was typing all those things, then the emotion is something like she was having a negative emotion, the negative sentiment, because that classification, if once you can do it, then we can just put it into the forensic science, like whether, I mean, she was murdered or something like that, murder or either suicide, or maybe like something like that. If suppose someone is happy and just found, I mean, he or she is died, I mean, she is dead after some time, we cannot just say like she has suicide, he or she has suicide, because when one is happy, how can it be assumed like he or she suicide? So that sort of thing can also be implemented when you go for the sentiment analysis. Apart from that, yesterday was a big example where things are being infused, where robots started loving you, robots started getting angry on you, and then hate you, whatever it be. So that is one thing. Then word segmentation. Say like in languages like Chinese, Japanese, Thai, these languages have a very unique structure. Maybe the one, say for example, let's pick up the Chinese or Japanese. Because like the Japanese, the Chinese have a character in terms of 1000, above 1000 characters. Like whatever they have written, that is not a single word. I mean, that is not a single character. That is a word actually. And suppose Chinese one. So Chinese is something like that, they have written it. Though that is not a character, that is a word. That is a word, so they have around some above 1000 characters. So the thing is like, on those cases, on those thing, they need segmentation of the word again in order to just read the message what is there in the word, particular word. So segmentation is important in that particular thing. Now the information retrieval. Information retrieval is generally what is applied much in the Google platform. When you try to type like, say for example, Mysore Palace in the Google search or search engine or something like that. When as soon as you type, there are a lot of websites coming up and then giving an abstract on that. So like the thing is like the information is being retrieved after just putting some word or phrase, or maybe like you can just put some related questions on that. When you put some questions, then it can come to question answering. But when you put a word and then try to search it, and since like it is giving a lot of information based on the particular word or phrase it's been given over there, then we call it as the information retrieval. So information retrieval is another area where people works on. Okay, now automatic summarization. This we have done it in when we were in our younger days, where the teacher used to summarize the whole chapter or something like that. So now the thing is like the system is summarizing. When you have a huge chapter of some 5 to 10 pages, the system will automatically summarize it based on the points which is very important. Or otherwise, in research paper we used to write the abstract. So that abstract can be deal with such sort of algorithm. So when you have a huge chapter, that can be definitely summarized. That is one more area where people can work. Then word sense disambiguous. The word can have multiple meanings and all. So this can be we can just make it disambiguous. Then speech recognition. Speech recognition is another area of NLP, where people used to just work on the concept of all this NLP through voice. So that is another area where people can work on. Now speech segmentation, when you go for the speech, then it goes with the speech segmentation, because the speech like is a flow of sound. You have to segment it like word by word. Then only you can just work on with the next step. So speech segmentation is another good area where people can work. Then you have multi-word expression. Multi-word expression is something, as I give an example, like to and fro, maybe kick the bucket. Kick the bucket doesn't mean like someone is kicking the bucket. If you look into the meaning of kick the bucket, means someone died, something like that. So those things are important when you haven't find all such words. When you try to translate the thing, machine will just give you a different meaning on what is what you have already written over there. So that is the reason why multi-word expression identification is also important. Then you have machine translation, because like it's happening. Google Translator and all did all these things. Like you type in one language and it will be translated into another language. I'll give you some example, working example also after this slide. And then the proofreading. Proofreading is another area where people can work on, because if you write a book, or otherwise if you wrote a book, the thing is like you have to look into the level of spelling. If you have to look into the syntax of the sentence, and then you have to look into the semantic level. So these three are important when you go for the proofreading. So spelling wise, it's easy again. Checking by human and checking by system, the system will do better spelling check, because we human may just have some error in checking the spelling, because we cannot just 100% sure, like we have checked the spelling 100% accurate. So system will definitely give it a very accurate one. So that is one thing. Then you can just check into the syntax also, because like MS Word, Grammarly and all this Trinity, then these are all doing all this stuff, because you already work on all those things. I think MS Word, when you go for the MS Word spelling mistake, there will be a red line. When there is a syntax error in the sentence, there will be a blue line sort of thing. And then if suppose you want to just give some certain option of other synonymous word or something like that, you can also get that suggested words and all. These are all happening because of all this proofreading sort of thing. Proofreading is another area where people are working. Now I can also give you some example on all these things. I'll just show you some example demo. This is a file. This is a Manipuri file, because like I'm just picking up the Bengali script. We also have the Maithemik script, but I'm just picking this example. I want to run this and then find the part of speech of this. Like this was the input file. This was the input file, and then after running the program, I got this sort of thing. Like each word I am being identified with certain tag, POS tag. So this is how it works. Like each word is identified giving certain part of speech tag. So tag also, there is certain standard. For the verb you have to use this, for the noun you have to use this. All these things are happening, and for each and every language everyone is working on this. This is one example. For example, the font is little small. So like this is for English. Like we'll try to identify the name in this very context. Like this is the word, this is the the paragraph I'm having. I just want to use classifier in order to classify the thing. Now the system is identifying all this particular name. Maybe like you look into the color over here. Like say for example, the orange will give you the organization name, the violet or the purple will give you the location name, and then this will give you this color will give you the person name. So these are the things. Like this software is just giving you the color or something like that, but it's not compulsory to give a color also. But only thing is like, just in order to focus on all these things, these are being shown with the color. This you can just get it from the Stanford University website also, especially for the English, because Stanford University is working on NLP like anything. Okay, you can visit the Stanford University and find it out also. So this is one example. And even for the part of speech tagging also, there is like work done for the English. Like you can just find it in Stanford University. You type anything, like say for example, I am typing like how are you. Okay, if I ask it to take it, it will definitely take it. Like how, then are, you, all these things. They will be typing it. They will just say, using the take, part of speech take. Okay, there is a standard take set. From that take set, automatically it will pick up and then it will try to take the word. So this is this for the English. Now, okay, now let's move on to the concept of the machine translation, because that was some of the example of that were some of the examples for the application of NLP. Let's move on with the concept of machine translation again, because in reality what is going to happen in future is something like this. The computer, and then we are, the computer engineers are proud that they just want to, they have the knowledge of programming, but after some time it will be something like one may not program after all. Okay, we don't need to program in the computer. The only option will be something like you talk in your own language. Okay, you talk in your own language, you give the advice, you give the instruction to the computer will automatically start programming of its own. That is the future. So the most important part is like the system need to understand your language. So in order to understand understand our language, we have all this like machine translation where you can just translate from one language to another language. That is the future. We know we don't need to learn any programming language maybe in future. Only thing is straight away talk with the computer will automatically program it for you. So that is the real target. So now, like yesterday I was talking about the neural network and all. So let me continue with that. And I also started mentioning about deep learning. Well, it will be little bit technical, but let's see like whether you can copy it up or not. Now I've also started talking about all the supervised and unsupervised learning. Now the thing is like deep learning can be considered to be supervised and both supervised and unsupervised learning. Okay, now thing is like we have artificial intelligence, AI. We were talking about AI. So now the thing is like after some time, at the beginning AI was a very different topic, different domain. Now the thing is like when you go into depth, then you started talking about machine learning, which I was discussing yesterday. We have started talking about machine learning because as I told you, like AI no more goes into the classical way. They started talking about the machine learning because the system started learning of its own. Now again inside this machine learning we started talking about deep learning. Deep learning is something where we human, it's almost a replica of how we human used to learn. Like the neurons are being used in order to study the environment, and then the message is passed from one domain to another domain. That is how it is happening. The same thing is happening when you talk about the deep learning. Now say for example yesterday this was the example where you give the inputs, the weight, and then it has certain functions and then it will give an output. Say for example if you want to identify a noun in a complete chapter, the thing is like I have to just give the data of all the nouns, like what should be the characteristic or whatever it be, or otherwise some samples of nouns, and then we'll put a weight whether, say for example if I'm giving multiple word over here, multiple words, maybe like in terms of lakhs I'm giving, this is not real, fixed only to one or two words. Here this input can be in terms of lakhs and lakhs of words, for example. Okay, that's why as I keep on telling, like it's all on data. It's all data dependent. That means like the whole thing will be data only. Now I'm giving certain weight in sense like if suppose x1 is a noun, I'll give certain weight like 1. If suppose if it is not a noun, I'll give 0. So like that there will be certain words over there. Based on that I'm giving certain weight on that, and then with certain algorithm, with certain mechanism, I'm going to identify which type of word will become a noun. So that is the way how we used to do it. So now another thing is like this is for a single neuron. There may be cases where you have multiple layers, where one layer will transfer certain output and then that output will be an input for the next layer. So that's how we can keep going. Now the thing is like, see here, the thing what is happening here is like we're having a layer over here, neural layer. Now the output of this neuron is being passed, it becomes an input for this. Now like again this output will be again an input for this layer and so on, and then the last output will be there, which means like the first layer will give some suggestion, the second layer will give some suggestion. That will be something like we are learning something like layer by layer, and then at the end when you pass multiple layer, the output will be something where all this knowledge are being accumulated and give a certain output. That is what is happening. And now the thing is like when you have multiple layer, we don't need to just remember all the layers. Okay, the thing is like what we have to focus more will be on the input layer. and what we have to focus more will be on the output layer. This layer which is in between will be something different. So that is the concept, that is the idea. So that is what has happened in the deep learning, and we consider deep learning with multiple layer, but the thing is like there will be some hidden layers inside. That is the concept of the deep learning. Now we have multiple options for deep learning also, otherwise neural network also. We have a lot of options like how you are going to do it. Maybe like you give certain iteration sort of thing. Sometimes you just straight away give input and then you wait for the output, or maybe like there are different networks. So it's like if you really want to go in depth with all this deep learning, all this neural network, then this is some of the few suggestions which you can just move on with. Now say for example recurrent neural network. Again, even though if we suppose here recurrent neural network, the thing is like in this neuron itself, the output given by this will be again fit there itself, unless that neuron satisfies. The output will be again an input to that neuron, and then there will be some sort of iteration sort of thing until certain level is reached, or otherwise until the neuron satisfies with the output. Then there will be some formation of loop. So that sort of thing is what is, I'm just picking up an example among all those things. Like say for example, you have an input. With the RNN design, you are waiting for an output. But the thing is like as soon as the output comes out, that output will be fit again as an input to the neural network. So that there will be a loop until there is some satisfaction coming, satisfactory output comes out of that neuron. That is one thing. So that is what is happening in recurrent neural network. And then let's talk about the shock computing also, because when I say like what computer knows, everyone says like the computer knows only 0 and 1, which means like yes or no. But the question is like, is it the right answer to solve a problem? Because when I ask you like, when did you become old? When did you become adult? When do you start loving someone? Do you have the answer for that? Because we were only just saying yes or no. Yes or no means like there is a bar. When you are in this side, you are yes. When you are in this side, you are no. But there is nothing like a gradual change. Do you ever think like when you have become adult, then did you ever observe on all those things? Never. When will you become old? Is there any fixed age, any fixed month, any fixed second that you will become old? There is nothing like that. There's a gradual change. So we cannot just stick with the concept of 0 and 1 every time as what we have understood in computer. When we talk about 0 and 1, it's only yes and no. And how this 0 and 1 is like, it's just a fluctuation of voltage. Okay, now the question is like whether, at this age and at this year, at this month, at this second, I'm going to become old. We cannot say like that. So there it comes the concept of shock computing, where shock computing just give you an idea where certain thing where gradual changes take place, then this is a good algorithm to implement. Because like we never know sometimes like whether I'm going to go or not. Always when you ask the computer will always ask like whether you are going or not. The answer should be either yes or no. But sometimes as a human, we feel like I may be going or I may not be going. I'm not fixed now. That means like shock computing plays an important role here, because the mood for deciding becomes a gradual change. It's not a rigid sort of thing, because whenever you talk about computer, it's a rigid one, 0, 1, but sometimes rigid doesn't work. So this shock computing gives another solution for what you call as the shock, another challenge, another solution to the challenge like 0 and 1. So there is nothing like rigid sort of thing. So when you talk about rigid things means like 0, 1, even the switch is giving you 0 and 1. Either you put it on or you put it off. But that doesn't work every time. Even in computer also, you cannot keep deciding like 0. Yes, of course, the basic concept of computing is 0 and 1. Whatever data you are going to fit in is going to just translate it into 0 and 1. But the decision making part, when it comes to decision making part, we cannot always rely on 0 and 1. Since like in human nature, because like we are trying to replicate the thing in the human nature into the computer. So like we cannot always be rigid, right? Whether, say for example, if I have to ask you like whether you want to take lunch, you cannot say yes or no, because sometimes you feel like you are in a confused state whether you are going to take lunch or not. So this algorithm gives you another example of the soft computing. Another solution for all those complex ideas. Now another part is what you call as evolutionary computing. This is another place where things are being discussed, because like every time what happens is like you have to have a pool of datas. You have a pool of data. Of that pool of data, you just want to pick up certain data for the experiment. It's not always like all the data will fit into it. Will always fit into it, and then that will give you a correct answer. Because sometimes there will be a pool of data, and then you want to just select some data. So in that case, you can also apply this evolutionary computing. What happened here is it's something like the same thing how we are being evolved. You have the genes, you have the chromosomes, because like my son will be inheriting my character and my wife's character. That is what we have learned in science. That is inheritance. That sort of thing is being applied here. When you have a pool of data, and you can also predict what type of answer, what type of next generation will, the characteristics of next generation will have. That is another option for that. This genetic algorithm will give you one option for that. Here what happens is like you have a pool of population. The thing is like the selection process will take place. Suppose if you are of some science background, then the Darwin theory is applied here. The Darwin theory, where the genes plays an important role in from the chromosome. So that is what is happening here. So the selection process will take place, then there will be some crossover in the genes, so that the offspring will be having certain characteristics, and then maybe like mutation will also take place, because like it's not always true that the characteristics of both the parents will come down there, because sometimes the grandparents characteristics also come to the offspring. So such things are happening, and then what happens is like you will have another new population, because you have an offspring now here. Offspring will definitely have certain new characteristics, and that new characteristics will go for the population, because then as soon as there will be a termination point also. Okay, so let's see, like I'll give you an example here. Say for example, if I want to find the multi-word expression. Okay, I want to find a multi-word expression in a sentence. Now the thing is like I try to create a chromosome. Okay, chromosome will definitely have certain genes. Genes gives the characteristics of each word. Okay, or say for example, the whole thing is, let's consider the whole thing as a chromosome. Now I am just considering each characteristic as a gene of that particular particular word. Okay, now I will be selecting among these genes. Okay, among the genes, like I'm having multiple genes over here. Genes in sense like the characteristics of this characteristic. What I'm doing is I'm selecting a certain characteristic by putting 1. With this character 1, when I put 1, see like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the 13th one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the number of acceptable suffixes. This is the characteristics I'm selecting from the gene. Okay, among the chromosome. So this is one chromosome. Of that I'm selecting one gene. This is another gene. So this is another gene I'm selecting. So in such a manner, like I am selecting certain characteristics. I'm playing game with the characteristics. It's not always true that all characteristics can fit it and then there will be a correct answer. So I'm doing an experiment where I'm just jumbling the characteristics, and then I'm trying to find out like which combination of characters gives the best output. It's not always true that if suppose you have multiple characteristics and then if you infuse all the characteristics, the answer will be highly accurate. It's nothing like that. We have to experiment by jumbling in sense like we'll try to find a lot of permutation and combination among the characteristics in order to find the correct answer. This is what is happening over here. So now you when you have the genes over here in one chromosome, if I want to select this gene, I'm putting it 1. If I want to just select I don't want to select this, means like I'm putting 0. So I want to select this, I'm putting it 1. So the chromosome is something like where all the genes are over here. I'm selecting the genes by putting 0 and 1. So this is how it happened. And this is how we do evolutionary computing or genetic algorithm. But I mean applying genetic algorithm in NLP. So this is one thing. So like I was doing for some part of speech and other thing. So like with the generation coming up, at last we find some certain accuracy at this level. Maybe like after 50 generation, after doing all this work for iteratively, and then at somewhere around some 50 generation we are getting some good accuracy. So this is how it happened. Now with the after 50 generation, the best characteristics becomes like this. This is the best characteristics combined in order to identify multi-word expression in Manipuri. So this is one experiment. And then the fuzzy logic. So fuzzy logic is a concept about the shock computing. Fuzzy logic is almost related with what we have discussed in shock computing. Fuzzy, that is the same thing, the same concept, because fuzzy is a part of shock computing only. I don't need to explain it again because it's a gradual change sort of thing. Okay, now this is one of the most highly used way of machine translation right at the moment, because like at the beginning for the machine translation, when you try to translate from one language to another language, we were depending on the rules, we were depending on all the other factors, because we have to move down to the part of speech, we have to move down with the spelling, we have to move down to the complexity of the word, everything we have to, we have to move on, we have to experiment on all those criteria when we were talking about machine translation at that time. But now with the coming of this neural machine translation, we call it as NMT, we don't need any of the rules. I repeat again, we don't need any of the rules, because like this may be the worst part for the linguistic, because we no more require any of the linguistic rule if you apply this sort of algorithm, because this is what is happening with the ChatGPT and all. ChatGPT or otherwise all this AI stuff, they are not implementing any rule, because this is purely a database, data dependent model, where you have a lot of data, and then based on the data you are having, the prediction will take place. The prediction, all these things will take place. So this is one of the thing setting up. I'll just see, like I'll tell you, like, because the thing is like we have to create parallel data. Suppose there are two languages, L1 and L2. We have to create two language, pair of language. Suppose I am talking in English and then I want to just translate into maybe Manipuri. There must be certain pair of language, and we call it as parallel corpus. L1, L2. We need to have a huge number of corpus, parallel corpus, because if we have to implement this NMT. Okay. Now other thing is like we have to check out all this duplication and all, normalization, tokenization. These are all few things which we have to implement. And then the thing is like this is the way how it is doing. This is the way how it is doing, because we have a concept of transformer. There is another in the NMT, neural machine translation. What happened is like there is a concept of transformer, because like someone was mentioning about LLM yesterday. Okay, large language model. Okay, the thing is like the term itself gives that suggests that you need to have a very large, huge, data, large language, especially for the language, and that we'll have to design a model based on that. It's not on the rule which we are talking about. So in this transformer model, from this transformer model, this LLM concept comes. So now here the thing is like the source input will be given, it will be encoded because by using an encoder, and then all this works on then again decoded. Okay, decoded in sense like certain statistical and probability reading will be done here. Okay, in both these two cases. After that, what happened is like there will be some classifiers. Okay, with the classifier, automatically it will be classifying the things. Classifier in sense like if you're working, if you're doing the implementing this for part of speech, the automatically the noun, verb, all these things will be classified. Or otherwise, if you're going for a machine translation straight away, the automatic answers will be given. Maybe like we have to think of the future in such a manner that every step we put need to be very careful, whatever it be. Like we are say after buying a mobile phone also, as soon as you buy, as soon as you bought the mobile smartphone and then you put on the phone, then you start typing yes, 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 I accept, I accept, I accept. We never read the data on that. We almost put like I accept, I okay, or something like that. But the thing is like you are giving a consent to the system that they want to just get data from you. And the consent is in such a manner that whatever you accepted, there will be some term and condition. We never read on that because the term and condition is so huge that who will read on that? We don't like it also because we always want shortcut. We never read on go. I mean, if we have to read on all these things, I think it will take another 1 week. I think in order to just start operating the mobile, I have to just keep it for 1 week, reading all the terms and conditions. Where you said yes or no after that. That will be very difficult part. We don't like that. So we need to be very careful, as I keep on telling, like whenever we do something, we are exposed. We are exposed up to some extent. Not up to some extent. Every time we expose. I'll tell you one more thing, like you may caught in surprise. You look into the Google record of your travel. Okay, the Google has keep a track record on where you travel also. You just check it in the Google. Sometimes they give you by surprise like which city you have traveled in this year or maybe something like that. That means like even you are, I mean your travel is also exposed. So what is not exposed now? Everything, every data is exposed. Like starting from taking selfie, we have already exposed our fingerprints or I mean iris or vocal, what not is exposed. So the thing is like we need to be very careful in every aspect of our life because this AI is going to create a havoc in maybe down the line in some 5 to 10 years. That's for sure. Please mark it. Okay, thank you everyone.